Today we're going to work on direct variation equations. Make sure you have your journal open to your direct variation foldable as we go through this. Throughout the video we'll be doing some examples together and then we'll be doing some independently. If you have to, make sure you pause the video so that you can get your examples done before moving on. Direct variation is a specific relationship in which there is a constant ratio of x and y. And our constant ratio of y and x will always be y over x between all ordered pairs. In direct variation, every ordered pair has the same ratio y to x. These are also called proportional relationships. So direct variation is a proportional relationship. Direct variation equations will always be written in the form y equals kx. K is being multiplied by x. K stands for our constant of variation, and there is never anything that is added or subtracted. If there's any addition or subtraction on this, it is not a direct variation or proportional relationship. Finding the constant from ordered pairs will be what we're looking at first. We want to identify the constant of the ordered pairs, and then we're going to write an equation to represent that relationship. I'm going to do numbers 1 and 3 with you, and then I'll give you a minute to do 2 and 4 on your own, or you'll pause the video to do 2 and 4 on your own. When you find the constant of variation from ordered pairs, they have told us already that these are direct variation. Our equation is y equals kx, where k stands for our constant. To find the value of k, in order to write our equation, we're going to plug in one of the ordered pairs. It does not matter which ordered pair you pick. You could pick 1, 4, 2, 8, 3, 12, or 4, 16. So as we plug these in, I'm going to choose the first ordered pair, 1, 4. Remember that in an ordered pair, x is first and y is second. So I'm going to put a 1 in for x. I'm going to put a 4 in for y. And I'm trying to find the value of k, or the constant of variation. To solve for k, remember we divide both sides by what it's being multiplied by. And we can tell that 4 divided by 1 is 4. So our constant of variation, or the value of k, is 4. And to write our equation, we're going to use our equation y equals kx. As we write this equation, we found that the value of k, or the constant of variation, is 4. So our direct variation equation is y equals 4x. Notice that the number is being multiplied by x, and that there is nothing added or subtracted to the equation. That is the only way that it can be a direct variation equation. Number 3, we're going to take a look at together. We're given a set of ordered pairs. We have -12, -8, -6, -4, 0, 0, and 3, 2. All direct variation equations will go through the ordered pair 0, 0, but we don't want to use those when writing our equation. So we're going to start with any of these 4. I'm going to choose our second set. They look easy to me, -6 and -4. Direct variation is always written in the form y equals kx. We're going to plug in -6 for x, and we're going to plug in -4 for y. It doesn't matter which ordered pair you choose, you will always get the same constant. To solve for k, we're going to divide both sides by -6 because it's being multiplied, and this reduces to a positive 2 over 3. It's okay to have a rational number for your value of k. So our constant of variation is 2 over 3. To write our direct variation equation, we have y equals, and then our value for k is 2/3 x. So this represents our direct variation equation. If you'll pause your video and try numbers 2 and 4. The next section we're going to take a look at is identifying the constant of variation from an equation. And then if it is, we're going to find that constant. If it's not, we're going to say, no, this is not a direct variation equation. Direct variation equations must be written in the form y equals kx, or be able to be written in that form if we need to manipulate or arrange our equations. You cannot have any addition or subtraction, and it has to be our number multiplied by the x value. Let's take a look at number 5 together, y equals 3x. Yes, this is a direct variation equation, And to find our constant of variation, it's going to be the number that is multiplied by x. So in y equals 3x, our constant is equal to 3. Let's take a look at number 6. This one is a direct variation equation. Y equals negative 4/5 x. Yes, this is direct variation. There is a number multiplied by x. Our value for k is negative 4/5. It is okay that that is a ratio or a fraction. Number 7, we have y equals 2. There is no value for x. That is just a constant. This is not a direct variation equation. We have to have that number multiplied by x, so it is not a direct variation equation. I want you to skip to number 9. Remember that direct variation has to have y equals a number times x. There can be no addition or subtraction. So for number 9, no, this is not direct variation because there is a number that is subtracted from x. You cannot have any addition or subtraction after the equation has been simplified for y equals. Skip ahead to number 12. On number 12, this says 4x plus 2y equals 6. We cannot determine right now if this is direct variation. We have to have the y value by itself in order to do this. We're looking for that y value. In order to solve for y, we're going to split our equation into two parts. We're going to subtract 4x from the left and subtract 4x from the right. As we subtract these, we get 2y equals negative 4x and 6 do not go together. They're not like terms, so I'm going to write them one at a time. It was a negative 4x and a positive 6. Then we divide by 2, and we're going to divide each term on the other side by 2. We end up with y equals negative 2x plus 3. If we look at this, we're trying to decide if this is direct variation. No, this is not direct variation. Unfortunately, we have that plus 3 at the end, which tells us it is not going to be direct variation. Take a minute to try numbers 8, 10, 11, and 13. Remember that you have to solve for y first, so you have to get it to say y equals. Make sure you do that. And it has to be a number times x. If you'll pause the video and finish those 4 before you move on. The next thing we're going to look at is our graphs. When you have a graph, the things you want to check, there are 2 things that you need to look for. The first thing, the graph must go through the origin. If it does not go through the origin, it is not a proportional relationship, which means it is not direct variation. The second thing that you need to check is that this must be a straight line. If it is not a straight line, then it is not direct variation. So you want to look, does it go through the origin, and is it a straight line? If it meets those 2 requirements, it is a direct variation equation, which means it is proportional. Looking at number 14, we have a line. It goes through the origin. It's a straight line, so yes, this is direct variation. To find our direct variation equation, remember that we have y equals kx. The value of k is the ratio of y to x, so we're going to choose an ordered pair anywhere on this line. We have an ordered pair right here at 2, 3. We're going to use these values to find our constant of variation. The y value is 3, the x value is 2. We're going to plug those in and solve for k. Divide both sides by 2. We find that the constant of variation is 3/2, so our equation is y equals 3/2 x. Our constant was 3/2. Number 15, we want to check if this is direct variation. Does it go through the origin, and is it a straight line? This does not go through the origin, so no, this is not direct variation. Next, we're going to look at number 16. Number 16, we have a line that goes through the origin. It is a straight line, so yes, this is direct variation. Now we need to find the constant. Y equals kx is our equation. If this is direct variation, we can look at an ordered pair. Here's an ordered pair. This ordered pair would be negative 4, 1. So the x value is negative 4, the y value is 1. We can use those to plug into our equation. Y is 1, x is -4. Solving for our constant, we're going to divide both sides by -4, which leaves us with -1/4. So our equation would be y equals -1/4 x. If you'll pause your video and try number 17, you're going to decide, is this direct variation? If it is, choose an ordered pair to help you write your ratio of y over x, and that will give you your direct variation equation. The last thing we're going to look at with our direct variation is finding missing values. This is our last section. If you're given an ordered pair like 2, -4, and then you have -6y, you're being asked to find the y value. Remember that these are proportional relationships. We use the equation y equals kx, so we'll do y equals our constant of variation times x. In our first ordered pair, we're going to use this to find our constant of variation. We put 2 in for x, and we're going to put -4 in for y. So we have -4 equals something times 2. As we work this, we divide both sides by 2. We're going to divide the right side by 2 and the left side by 2. When we divide the left and right by 2, we find that our constant of variation is equal to -2. So k is equal to -2. Using this value, we can find our missing number in our ordered pairs. We have y equals -2 times x. From our second ordered pair that is missing the value, we see that x is equal to -6. So we're going to plug in -6 in our x value since we have our direct variation equation with our constant. So y equals -2 times the x value of -6. And we know that -2 times -6 is equal to a positive 12. So our missing value would be 12 for y. So y equals 12. If you'll skip down to number 22, this is the same type of equation. If y equals -18 when x equals 3, find x when y equals 30. We are given a piece of data. We know that this information would be our x and our y. We're going to use that to find our constant of variation. So in a direct variation equation, y equals kx. That is our direct variation equation. We're going to put in -18 for y. We're going to put in a 3 for the value of x. To find k, we divide both sides by 3 on the left and the right. So our constant of variation is a -6. We're going to use that to make our direct variation equation. Y equals -6 times x. They're asking us to find x when y equals 30. So we're going to plug in 30 for y. They're giving us the value of y. Put in 30 where you see the y in your direct variation equation. This is equal to -6 times some number. We're going to divide both sides by -6, and we find that our missing value x is equal to -5. If you'll take a minute to pause the video and you're going to finish, I want you to do numbers 21 and number 25. So you're going to do 21 and 25. You do not have to do 19, 20, 23, and 24. Finish 21 and 25. And if you have any questions, make sure you write those down, and we'll be going over this in class tomorrow.